Edexcel, May 2019, AS Maths, Paper 2, Stats and Mechanics, Calculator, Pen, Hangover. Let's go. A 6-1 college has 84 students in Year 12 and 56 in Year 13. The head teacher selects a stratified sample of 40 students stratified by year group. Describe how this sample could be taken. Right, let's have a bit of a think about this, right? It's stratified by year group, meaning that this sample has to be representative of like the amount of Year 12s and Year 13s. Like, if there are more Year 12s than Year 13s, there should be more Year 12s and 13s in the sample, right? It wouldn't make sense to have 100 Year 12s and 2 13s, and then I take a sample of like 4, and it's like 2 of each, right? Because it's not really representative if there's a lot more Year 12s. So I need the kind of ratio. How many have we got? 84 and 56. This is the ratio of Year 12s to 13s. Let's simplify this. So what we could do, just do like 84 divided by 56 in your calculator. That's 3 over 2, meaning that this is actually just the ratio of 3 over 2 here. So what we can do now is we can say, look, this needs to be, 40 students big. So essentially, this is kind of like, in GCSE where it's like, Alice and Bob share 40 quid in the ratio 3 to 2. It's that kind of thing, right? We just need to work out how many Year 12s and how many Year 13s should be in this sample now. So what you do in them Alice and Bob questions is you would add these numbers together, right? So you would kind of have it in like chunks of 5, right? 3 plus 2. So then what we would do is we would say, okay, well, how many chunks of 5 are going to be in 40? If I did 40 over 5, that's going to be 8, right? So now, if I do 3 times 8, that's going to be 24. And if I did 2 times 8, that's going to be 16. And that works out, right? Because 24 add 16 is 40. So that means that I want 24 Year 12s, 24 Year 12s, and 16 Year 13s, right? Let's get this a bit bigger so you can actually see what I'm doing. So that's the kind of stratified bit. We need to actually kind of describe a method though. So you would kind of want this to be random. What you could potentially do, they like this, right? They like saying, like using random number generators. Just Google it, right? Random number generator, generating me a number between 1 and 100, whatever. So what you could potentially do is you could assign a number to each of the students here. So for example, like the 84 Year 12s, I could literally label the Year 12s. Don't like stick a label on their head, but just like assign them a number, right? The numbers 1 to 84. And the Year 13s, 1 to 56, right? And then what we can do is just for each of those, just choose how many Year 12s do you want? We want 24 of them. So we can basically do that random number generator between 1 and 84 24 times. And then they'll be like, right, whoever's number's been called out, you'll be in the sample. Do the same thing for the Year 13s, 16 times. So then you're sure to have 24 random Year 12s and 16 random Year 13s. So, and then run from 1 to 6, use a random number generator, to basically select the 24 Year 12s and the 16 Year 13s. I think that should do the job. Pretty boring stuff. Now, the next part says the head teacher is investigating the relationship between the amount of sleep, S hours. Very relevant for me today that each student had the night before they took an aptitude test and their performance in the test P marks. For the sample of 40 students, he finds the equation of the regression line of P on S to be that. With reference to this equation, describe the effect that an extra 0.5 hours sleep may have on average on a student's performance. So what this regression line is doing, it's obviously not perfect, but it's using the data that the head teacher has. Basically saying, like, you tell me the amount of sleep they got, and I'm going to put this into an equation to give you the mark on the test, right? So what have we got? We've got P equals 26.1 plus 5.6 S. So it's basically saying, if they got no sleep, what score would they get? You would put S equals 0. If they got 1 hour sleep, what score did they get? You would put S equals 1, work it out from this formula, right? So essentially, it says, describe the effect that an extra 0.5 hours of sleep may have. So this is the bit with an S, isn't it? So if I increase S by 1, well, what's going to happen to this? Like, imagine S equals 0, I'd have 26.1. S equals 1, I'd have 26.1 plus 5.6. S equals 2 plus 2 lots of 5.6. So it looks like for every hour that I add on sleep, I get an extra 5.6 marks in this aptitude test. So if S goes up by 0.5, it's going to be what? Half of that, which is what? 2.8? So essentially, I would probably say that, yeah, an extra 0.5 hours sleep would kind of, on average, give a score increase of, yeah, 5.6 over 2, which is 2.8. Think that would do the job here. Again, obviously that's, you know, it's not perfect, is it? Like it was got just from a bit of data that was available, but there's obviously going to be a lot much more at play. It's kind of on average. One limitation of the model. Right, okay, well, could I just say, oh, I want to get a high score. Why don't I just sleep for 100 hours a night? And then I'll get some mad score for P. Well, obviously not, right? There's going to be some limitation. Like there is a limitation to the amount of hours of sleep you can have in a given night. I mean, I suppose really, if you were to count like a night or like a whole day, it'd be 24 hours, wouldn't it? So like S would have to be between, I suppose, 0 and 24. And then obviously, you know, it's not exactly optimal to sleep 24 hours as well. So there's going to be more than that, isn't it? Like, because maybe around 8 hours, then more sleep might not do much. You know what I mean? It's obviously more beneficial to a certain point, but then, you know, you sleep 15 hours, it's not really going to help your cognitive function, is it? So, you know, I mean, here, yeah, 0 and 24, that's, you know, a definitive cutoff, so I'll just go for that. Question 2. The Venn diagram shows 3 events, A, B, and C, and their associated probabilities. B and C are mutually exclusive, and A and C are independent. Showing your working, find the value of X, Y, and Z. Ooh, okay. So let's get this diagram up here. What does mutually exclusive mean? It means they can't happen together. So it's like winning and losing a football match. You can't win and lose a football match. So if two things are mutually exclusive, in this case B and C, it means that the probability of B and C happening together is 0. It's impossible. What is that represented by on the Venn diagram? It's the intersection between B and C. So all of this stuff here, right? We know that that can't happen. Therefore, all of this must equal 0. So if I was to take this probability, which is 0, add it to this probability, X, I'm going to get 0. What does that tell me? It tells me X is 0. Cool. That's the first bit of information. Cashed it in. A and C are independent. Okay. What does that mean? That's a bit more complicated, but essentially it means the following. It means that the probability of A and C happening is the same as the probability of A multiplied by the probability of C happening. So let's work out the left-hand side. So A and C, again, is the intersection of A and C. So it's kind of all of this stuff in blue here, right, where the circles overlap. And that's just going to be Z, isn't it? It's going to be Z plus 0, so it's going to be Z. And then the right-hand side, the probability of A, well, that's going to be the A circle, so 0.1 plus Y plus 0 plus Z. So that's going to be 0.1 plus Y plus Z. And then the probability of C is the C circle. So the C circle is going to be 0.39 plus X plus 0 plus Z. Now we know that X is 0 and that's 0. So this is going to be 0.39 plus Z. Cool, so I've got another equation. Now I've clearly got two unknowns here. So that's really not enough information right now to get those values. I need another piece of information as well. What is the other thing that must apply to probabilities? It is that everything has to add together to make 1. So everything here, add it together, stick it equal to 1, you got yourself an equation. So if I was to do 0.1 plus Y plus 0.3, that's 0, plus Z plus 0.39 plus 0.06, there's a lot to deal with right now, all of that's 1. Okay, so let's sort all these numbers out, yeah? So I'm going to get Y plus Z equals, and take all them numbers over to the other side. So it's 1 minus 0.1 minus 0.3 minus 0.39 minus 0.06. Ugh. Stick it in your calculator. Okay, so I've got 1 minus 0.1 minus 0.3 minus 0.39 minus 0.06, 3 over 20, or 0.15. Okay, I've got simultaneous equations now, haven't I? I have got one here and one here. So this one looks a bit grimmer, doesn't it? Because it's got like, I'll have a z times z, it's going to get a bit quadratic. So why don't I use this one here to eliminate one of the variables? And it doesn't really matter which one you do. Why don't I eliminate y? So this one here, if I take z, I'm going to get y is 0.15 minus z. Stick that in here, yeah? So I'm going to get, let's see if I can get it all in here. It's probably going to get messy. Cool, right. So I'm going green. So z is going to equal 0.1 plus y, so plus 0.15 minus z, that's y, isn't it? Plus z times 0.39 plus z. Yeah, that's that, isn't it? Spoke as if there was more coming, but that was it. So this actually simplifies pretty nicely. Z minus z is 0. 0.1 plus 0.15 is 0.25. So I get 0.25 times this. And I think this is okay now. Let's multiply this out. So I'm going to get 0.25 times 0.39. Let's work him out. Some grim number, 0.0975. And then plus 0.25z. And then I've still got a z chilling here, haven't I? Take away 0.25z to leave me with 0.75z equals this grim number here. And divide by the 0.75 to get answer divided by 0.75 is 13 over 100 or 0.13. That sounds reasonable. So now all I need to do is get y, which I can sub straight back in as 0.15 minus 0.13, which is going to be 0.02. So my answers are going to be 1, 2, 3. And I believe that should do us for question 2. A fair five-sided spinner. And sides numbered 1, 2, 3, 4, and 5. Oh man. The spinner is spun once and the score of the side it lands on is recorded. Write down the name of the distribution that can be used to model the score of the side it lands on. What is popping off here? I'm hearing words, I don't get it. Essentially, a distribution is kind of saying, well, what are the different values that this thing can be? And what is the probability of each of those values? So what are the different values? If I called, the number of the side it lands on x, what are the different values that x can be? Well, it could be 1, 2, 3, 4, or 5, couldn't it? And then I say, well, what is the probability that, this x is equal to that value? So what is the probability that I get a 1 here? Well, it's fair, isn't it? And there's 5 options. So surely it's 1 over 5. What's the probability I get a 2? 1 over 5. 3, 1 over 5, etc., etc. So what is the name of this distribution? There's a couple of things you need. The first thing is it discrete or continuous? Discrete means it can only take set values. Continuous means it can take any value. So a discrete distribution could be this, because it can only be 1, 2, 3. It can't be 1.5. Can't be 3.14268, can it? It can just be discrete values. Someone's height, for example, would be continuous because you can be 173 centimeters tall, but you can also be 173.1, 0.11111. So this is discrete. And then what is it called when all of the probabilities are the same? Well, this is called a uniform distribution. Like uniform means like the same. So it's a discrete uniform distribution. So you don't have to do the top table, by the way, for your answer. That was just me explaining it to you. Literally the marks, or mark maybe, would be here. Discrete uniform distribution. That is all you need. You can have a think of other things that would be a discrete uniform distribution. What about the score I get when I roll some dice? You get it? So the spinner is spun 28 times. The random variable x represents The number of times the spinner lands on 2. Find the probability that it lands on 2 at least 7 times. Okay, what's going on here? I'm repeating some experiment, aren't I? Right? Like, I'm spinning the spinner, and then I'm spinning it again, and then I'm spinning it again. There's no difference in the probabilities each time I spin it, right? And then I'm kind of defining a success here. Now, yes, 5 things can technically happen when I spin a spinner, right? It can go on 1, 2, 3, 4, 5. But for all I care, it either lands on 2 or doesn't, right? So in terms of what I care about, that's actually just 2 options. It's a success, landing on 2, or a failure, not landing on 2. So this is a binomial, isn't it? Because that's exactly what a binomial does. It's you repeat an experiment, and then you are counting how many successes you have. So what I can do here is I can say, well, this thing x is definitely binomially distributed. I've got 28 trials because I'm repeating this, spinning it 28 times. And then the probability of success would be getting a 2, which would be a 5th, right? So then the probability of failure here would be 4/5, because it's basically the probability I get anything that's not a 2. So now it's saying find the probability that it lands on 2 at least 7 times. Well, that would just be the probability that x is greater than or equal to 7, wouldn't it? Now, you can use your calculator for this. My calculator only gives me less than or equal to probabilities. So what I need to do is the following. I need to say, okay, well, it's a discrete distribution, right? It can be, 7, 8, 9, 10, etc. So let's say you got 6, 7, 8, 9, 10, da-di-da-di-da, da-di-da-di-da, right? I want all of this, don't I? Greater than or equal to 7. So if everything is equal to 1, I could do 1 minus all of this stuff here, wouldn't I? So that would be everything less than or equal to 6, because then that's just going to leave me with what I want. If you have a calculator where you can just do an upper and a lower, you don't have to do that. So I'm going to get this, and then I'm going to do 1 minus answer. So if I go menu, and then I go down to distribution, I'm going to go binomial CD. Variable, and I'm going to put in my value of n and p, which is 28 and 1/5. X, I'm now going to put in 6. And that gives me this bit here. So I have 1 minus, and then I got what? 0.678, blah, blah, blah. Press menu and 1 to get back into normal mode, and press 1 minus ants, and that's going to get you my answer here. So that's going to be 0.3215, blah, blah, blah. Now, why don't we round this to like 3 sig fig? So that's going to be what? 0.322. Sweet. Find the probability that x is greater than or equal to 4 and less than 8. I suppose we can just do similar kind of thing, can't we? We can work out, in terms of like stuff that we can get from our calculator. So let's have a think, right? What have we got? 4 and then 8. Okay, so here's the thing. Like, what do we want? Let's grab this. Do a similar kind of thing. So we want, let's get some more in here. You got, 1, 2, 3, 4, 5. So we want 4, 5, 6, and 7, don't we? And then we don't want 8 because that's not inclusive there. So here's something I could do. I could work out the probability that it's less than or equal to 7, which would get me everything here. So if in green, right, I did the probability less than or equal to 7, that would get me all of that. So what's extra? What do I not want here? Well, I don't want everything in yellow, which is this stuff here, isn't it? So if I did the green minus the yellow, which is what? The probability x is less than or equal to 3, then I'm going to be left with what I want. So again, we've got all the stuff in our calculator. Go back to menu, distribution, binomial, CD, variable, and then we're kind of doing a similar thing, right? N and P is still going to be 28 and 1/5. So 28 and P is 0.2, 1/5, whatever. Let's first of all do x is 7. And let's get that value. So that's going to be 0.818232, blah, blah. Just go enough decimal places, because I'm not going to be using ants here, because I need to work something else out as well. So I'm going to do that, and then I'm going to minus. I'm just going to press equals again to get me back to this. My n and p are still there, so I just need to change x to 3. This is going to be 0.1601827, blah, 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 blah. Work this out. So go menu 1, write this out. So I've done more than enough accuracy here. So 8182302 minus 0.1601827. Just go over the top, right? And then this is what 0.658. Blah, blah, blah. I'll round to 3 sig fig again. So 0.658. And I believe that is it for question 3. Question 4. Joshua is investigating the daily total rainfall in Herne. Oh, I'm feeling some large data set here. For May to October 2015. Using the information from from the large data set, Joshua wishes to calculate the mean of the daily total rainfall in Herne from May to October 2015. Using your knowledge of the large data set, explain why Joshua needs to clean the data before calculating the mean. This is because there's bits of the large data set with this rainfall where they don't give you a number, they just say like TR, I think, which means trace. In other words, it's just like a trace of rain. Like there's barely any rain. And I think that corresponds to something like a rainfall less than like 0.05 millimeters, like almost nothing, just a trace of rain. And they literally don't write the number, they just write TR. So obviously if I'm trying to calculate a mean, add up all the values, divide by the amount, I can't add up something that isn't a number, right? I can't add up a TR. So what I would need to do is I would need to convert the TRs to like a number first, basically. So yeah, I would say like the trace data, or the trace data values, whatever, need to be converted need to be converted to numbers before calculating the mean, essentially. Because instead of just giving a number, they just write TR instead. Part B, okay, so basically, we get some information in a grouped frequency table. It then says, use linear interpolation to calculate an estimate for the upper quartile of the daily total rainfall. Right, so upper quartile, if you think of kind of everyone here, the median is where you just go in the middle, right, kind of at 50%. The upper quartile is where you go at 75%. And that's 75% like of the total frequency kind of thing. So I need to work out what number that corresponds to. So what I'm going to do is I'm going to work out what the total frequency is, like how many days are in this data set. So if I was to do 121, add 10, add 24, add 12, add 17, I get 184. So there's 184 in total. What is 75% of that? Well, let's do 0.75 ants. I get 138. Cool. So the upper quartile is basically going to be like the 138th data point if they're all in order. Now, obviously we're estimating this because we don't know the exact values, we just know what groups they're in. So what we do is we say, okay, well, let's kind of assume everyone's, distributed nice and even in their groups. First of all, we go, well, where does the 138, like what group does that lie in? So the first group has 121 in it. The second group has 10 in it. That means that after the first two groups, you're at 131. And then the next group has 24 in it. So if you think of these groups, right, by here, you've got 131 people. And then you add another 24, and that's, what's that? It's 100, oh, my maths today, man, 155, right? At 24 to 131. So it's in there somewhere, isn't it? It's probably around here or whatever. So we need to find exactly where in this group it lies, and then we need to find what numbers these correspond to. Well, the start of the 131, that's at 1, isn't it? And this is at 5. We're in the 1 to 5 daily total rainfall group. So we're somewhere between 1 and 5, and we're just going to assume that everyone in this group is kind of uniformly distributed across. So I'm that certain proportion through the group. So what I can do here is I can say, well, okay, I'm at 138, aren't I? So what's the size of this group? It's 24. And then what's the size of this line here? It's 7, isn't it? So I'm almost like 7/24 into this group, right? So 7/24 into the group. That's where I am here as a fraction of the whole length. So then I say, okay, we'll multiply that by, what the length of this group is in terms of the rainfall, and that's going to get me kind of how far I am in terms of the rainfall. Okay, so what I'm going to do is I'm going to do 7/24 multiplied by 4, because that's this kind of class width. Let's work that out. So that's going to be 7 times 4/24, which gets me like 7/6 or 1.16 da-di-da-di-da. Let's go 1.1. Let's go 7/6 for now, and then I'll turn it into decimal in my final answer. So that would almost tell me that kind of this corresponding length in terms of these numbers is 7/6. So then it would just be 1 plus 7/6, wouldn't it? So 1 plus 7/6. So if I do 1 plus ants here, that's going to get me 13/6. Or why don't we round this to 3 sig fig, which is going to be 2.17. That's linear interpolation there. Calculate an estimate for the standard deviation of the daily total rainfall inherent from May to October 2015. So we just need to know the formula, but it is in our formula book, so don't worry too much. It's using these summary statistics, this sigma notation stuff here. Essentially, the standard deviation is going to be the square root of, and then it's the sum of the x squared, or fx squared kind of in this case, over the sum of f, or the total amount there are. And then it's going to be minus the mean squared, and the mean is basically what? It's going to be the sum of f of x over the sum of f, or n, whatever. What was that f? There we go, and then all of that squared. So this is easy because they've just given us all of these things, haven't they? So this bit is the 7704 da-di-da-di-da. 1875, I'm going to need more space here, let's be honest. And then the sum of f is that total frequency that we added up before, and I believe that was 184. And then minus the 539.75 over 184, and all of that's going to be squared. And then this whole jobby over here is going to be square rooted. So just stick it into your calculator, and it's going to be square root of just everything you see here, stick it in the calculator, right? And hope for the best. So over 184 minus 539.75 over 184 all squared, and then that's in a square root, and that should do it. So I get 5.7723 significant figures. Part D says, state the assumption involved with using class midpoints to calculate an estimate of the mean. Yeah, so that is basically this thing, like, you've got these classes, haven't you? Now, you don't actually know where people lie within the classes. It could be that, look, imagine this is like 1 to 2 millimeters, 3 to 4 millimeters, 2 to 3 millimeters. It could be that actually the ones in this class, they were all over here, right? Or they were all over here. We don't know. All we know is that there's this many between 1 and 2. So what we instead say is we go, look, this might not be the best assumption, I don't know, but let's just assume that however many are in here, they're just nicely uniformly distributed through this. So, just at set intervals, that's where they are, because we don't know any better, right? And that is why we would say, okay, well, if they're all uniformly distributed, then essentially they'd all even out to basically go to the middle, wouldn't they? Because the middle is going to be like the average of the ones in here. So, if I have this many to the left and this many to the right, that's just the same as basically having everyone in the middle, isn't it, in terms of the mean? So that's the assumption we use. We basically just assume that, the data points within each class are uniformly distributed. And that's, we also did that for the linear interpolation when I was just saying, oh, I'm just going to be this fraction through here, basically. That was, it's only if they're uniformly distributed throughout that class. So using your knowledge of the large data set, explaining this assumption does not hold in this case. So it turns out in the large data set, which again, The only way you're going to know this is if you just know the large data set. There's nothing I can just tell you here to make you know that without reading it yourself. But essentially, there's a load of points that are actually just 0, right? Just really dry places. So here's the thing. This 0 to 0.5 class, the majority of them are actually just 0. So if you think of this class, 0 to 0.5, the assumption in calculating the mean was that, they're uniformly distributed. But in actual fact, kind of looks a lot more like basically this. They're all just right here, and then there might be 1 or 2 over here. So definitely, they would not average out at the midpoint in this case, would they? So I would basically say that, loads of values are 0. So the 0 to 0.5 class, isn't uniformly distributed at all, basically. Distributed. Cool. And then, would you expect the actual mean daily total to be larger than, smaller than, or the same as the estimate? Right, well, we've kind of answered that here. Given that in action, so we assumed it was like this, but in actual fact it's like this. Therefore, the mean's definitely going to be a lot smaller, isn't it? Because the actual mean, is going to use this average value of a number much lower than what we used here. So we would say the actual value, I just can't type, man. Actual value would be much smaller, or well, not much smaller, just smaller. Yeah, because the first group has more values closer to 0, or at 0, than the 0.5, basically. So it's, the mean of that group is going to be lower, bringing everything down with it. Cool. Past records show that 15% of customers at a shop buy chocolate. The shopkeeper believes that moving the chocolate closer to the till will increase the proportion of customers buying the chocolate. Fair enough. After moving the chocolate closer to the till, a random sample of 30 customers are taken and 8 of them are found to have bought chocolate. Carries out a hypothesis test, 5% significance level. Hypothesis test is shown below. All of that stuff. Identify the first 2 errors that Julie has made in her hypothesis test. All right, let's have a look at it. So she said that H0 is that P is 0.15, 15% of customers makes sense. H1 is that P is, okay. So if H0 is that P is equal to 0.15, H1 has to be completely different to that, right? Mutually exclusive with it. But this is saying that P is greater than or equal to 0.15. Surely it should just be P is greater than 0.15. Because P is greater than or equal to 0.15 shares stuff with the P equals 0.15, right? They need to be completely different things. That's the point of a hypothesis test. You think that something is different. So essentially, H1 should be that P is just greater than 0.15, not greater than or equal to. P is greater than 0.15. K mass. Select X as the number of customers who buy the chocolate. Fine. So it's distributed binomially 30, 0.15. Fine. Here we go. She's worked out the probability that X equals 8 is 0.0420. But what you actually want, you need the probability of the tails. In other words, like less than or equal to or greater than or equal to probabilities. So you actually should be working out the probability that X is greater than or equal to 8, basically. You want to find, again, like these ends, these tails. And I believe, that's actually the 2 errors. So that's it for part A. Explain whether or not these errors will affect the conclusion of her hypothesis test. Good question. Okay, so the first one, no, we just need to swap that for greater than. But the second one, well, this might be a different probability, right? Like, she got a probability of 0.042, so she rejected it. But if we were to actually work out this probability, because, this is what she did. She worked that out, which makes sense, less than the significance level. But if we were to work out this probability and it was greater than the 0.05, then we can't reject it, can we? So let's work it out. So if we go to menu, well, again, we're going to need to do that old thing that we did with the binomial last time, right? It's basically 1 minus. less than or equal to 7. So let's work this out. So again, distribution, binomial CD. We've done this before. Variable. X is going to be 7, N is going to be 30, and P is going to be 0.5. Stick them in, and I get this thing. And then I need to do the 1 minus, don't I? So let's go menu 1, and then 1 minus ants. And that's going to be 0.0698. Let's go for. So this is actually greater than the significance level, isn't it? So now, you know, the way that she did it, it was less than the significance level, but the proper way, it's actually greater than. So yes, it is going to affect the conclusion because it's now not small enough for us to reject the null hypothesis. So, you know, we can say that the probability is now greater than the significance level. So we do not have enough evidence at the 5% level to reject H null. So yes, it does change her conclusion, basically. Sick. I hope we're not going to have to do this ourselves now. Let's see. Find is in a 5% level of significance the critical region for a one-tailed test of the shopkeeper's belief. Okay, so critical regions. Now, this can be a bit confusing, but bear with me. So essentially, we need the tail, right? So we know it's going to like look like this. So we need, you know, the probability of x being greater than or equal to some critical value to be basically less than 0.05, right? We need kind of the biggest critical value, no, the smallest critical value such that this is less than 0.05. Now, because my calculator can't work this out, I need to basically do this bit of logic, but with this algebra. So essentially saying that the probability that x is greater than or equal to something is just 1 minus the probability that it's less than or equal to that thing minus 1. Like here it was 8, so it's 7. So here it would be CV minus 1. So what I now need to do is rearrange. So I want to get this on its own, so I'm going to add this and then take the 0.05. So I'm going to get the probability that x is less than or equal to CV minus 1 is going to be greater than 1 minus 0.05, so 0.95. Okay, so now what I need to do is I need to just work out this whole number, the CV minus 1, using trial and error on my calculator. And then once I get that, I can add 1 to get CV. So I need the number so that it's just bigger than 0.95, right? So let's go menu, 7, binomial CD, yet again, variable. Okay, so N and P, this is the 30 and the 0.15 still. And now I just need to start trialing an error, right? I don't know, let's just put in x equals 10, for example. Okay, that's like 0.99, so that's quite a lot bigger. So let's go down. Let's go x equals 9. That's 0.99 still, so, you know, I'm still way too high. Why don't I go x equals 6? Okay, 0.84, so that's too low. So I'm honing in. Let's go 7. 0.93, that's not high enough, but an 8. Fantastic. Okay, so 8 is the smallest. That gives me the smallest probability that's still bigger than 0.95, right? So this gives me that, 0.972, blah-de-blah-de blah. Therefore, CV minus 1 is equal to 8. Therefore, my critical value is actually going to be 9. This is the bit that confuses people quite a lot. I explain this a lot more on AI Tutor, but essentially a lot of people get to this stage, forget to add 1 to it. So essentially, if my critical value is 9, therefore, my critical region is just going to be any x value greater than or equal to 9. So we can maybe put it in some nice set notation like that. Part D says find the actual significance level. Okay, so the actual significance level is to do with this, isn't it now? Because the actual significance level is basically, well, what is, the probability of kind of this thing happening? So what I need to do here is I need the probability of me being in the critical region, right? So the probability that x is greater than or equal to 9, well, it's just 1 minus this, isn't it? It's 1 minus the probability that x is less than or equal to 8. Do I still have this in my calculator? I do. So basically, just go to menu 1 and then just do 1 minus ants. And that is going to get you your actual significance level. Again, if this is confusing, I talk about it in a lot more detail on AI Tutor. It's quite complicated, so I don't want to spend 20 minutes on it doing an exam paper. But I believe that should do it for question 5, and therefore stands. On to the mechanics, and look at the size of that! Ooh. Time t is 0. I'm just going to read this quickly. You can read it yourself. Okay, parachutist falls vertically from rest from a helicopter which is hovering at a height of 550 above the ground. Parachutist models a particle, evolves 3 seconds before a parachute opens. She's fallen before a parachute opens. She's modeled as falling freely under gravity. The acceleration due to gravity is modeled as being 10. Using this model, find the speed of the parachutist at the instant her parachute opens. We can just SUVAT it up, can't we? Because we know things. We know, for example, that at the start, she's just chilling in the helicopter. She ain't moving. So her initial velocity is going to be 0. We also know that her acceleration is 10 because we're being told that. We also know that she's been falling for 3 seconds. So that's enough information to get V, isn't it? So all I need to do now is V equals, this is the easy one, isn't it? U plus AT. So it's going to be 0 plus 10 times 3, which even I don't need a calculator for that one. It's 30. Sweet. When her parachute is open, the parachutist continues to fall vertically. Immediately after it opens, she decelerates for 12 meters per second squared for 2 seconds before reaching a constant speed. She reaches the ground with this speed. The total time taken by the parachutist to fall the 550 meters. I'm burping, not a good day. To the ground is t seconds. Sketch a speed time graph for the motion between t and 0 and t. Okay, let's get some axes up in this. Boom. Boom. Okay, well, we've got V up here, we've got T down here. So she starts at rest, so she's going to start here at 0, right? And then she accelerates uniformly, at 10 for a bit, for 3 seconds. So that's just going to be a straight line going up here like this. Now, what happens after that? She opens the parachute out, okay? And then she's going to fall sharply, She decelerates at 12 meters per second squared just for 2 seconds. So the gradient of this is 10, but the gradient of the other bit's going to be minus 12. So it's going to be steeper, isn't it? So it's going to maybe go like that, quite steep and for less time. Let's fill some times in. This first bit's 3 seconds. This is another 2 seconds, so that's going to be 5 seconds. This goes up to 30, doesn't it? As we just worked out. We could work that out. Maybe we can make a bit of a note of that. I will potentially do that now just to fill in the graph. But let's just kind of work out what the rest of the graph's going to look like first of all. So if I was to then... Okay, so she decelerates and then reaches a constant speed. And then she reaches the ground at that speed. So from here on out, she's just at this speed, isn't she? And a constant speed on a velocity time graph or speed time graph is just a straight line. And then here, she's going to end it at big T. So that's basically it. But I suppose we could work this out, couldn't we? So I think that's going to help us anyway. So why don't we do that? So what I could do here is I could do a SUVAT just on this bit of motion. So in other words, a SUVAT from when she's at 30 to whatever this is. So if I SUVAT it up, I don't know S. I know that U is 30 because she's starting here. I want the final velocity. I do know that A is minus 12 because she decelerates at 12. T is going to be 2 because there's 2 seconds here. So if I have V plus there, V equals U plus AT this, what am I going to get? I'm going to get 30 minus 12 times 2. 12 times 2 is 24. 30 minus 24 is 6. Okay, so this is 6. And I think that's going to help us out a lot. The next part says, find the nearest whole number the value of t. So t is the only unknown on this, isn't it, really? So I can probably use some other nice piece of information to get it. I have not yet cashed in the fact that this whole, in this whole graph, all this motion, the total distance travelled is 550 meters. But here's the thing. I can get the total distance travelled from the area under a speed time graph. So if I just got the area of all of this, set it equal to 550, I can get an equation with t in it. So it's really just kind of three bits of motion. So this chunk, which is a triangle, this chunk, which is a trapezium, and this chunk, which is a rectangle. So the first chunk is going to be half base times height, right? So it's going to be a half base, which is 3, times height, which is 30. And then this is a trapezium. So trapezium is what? It's a half a plus b, which are these kind of green heights. So that's going to be 30 plus 6. Times by h, which is the width of that trapezium, which in this case is 2. And then a rectangle, we know how to do that. It's going to be base, which is t minus 5, times height, which is 6. All of that has to equal 550. So at this point, I just do the maths, right? So half times 30 is 15. Times that by 3, I get 45. A half times 2 is 1, so they kind of cancel, right? I just get 30 plus 6, which is 36. T times 6 is 6t. Minus 5 times 6 is minus 30. 550 is 550. So all I need to do to get t is I need to take all of the numbers onto the other side. So I'm going to be left with 550, add the 30, minus the 45, minus the 36, and then I'm going to need to divide by this 6. Straight to the calculator, and you should get the following. So 550 plus 30 minus 45 minus 36 all over 6 gives me 499 over 6, or kind of like 83.16, blah de blah. So I suppose I could go, does it say, name is whole number, so it's going to be 83, isn't it? Brilliant. Okay, in a refinement of the model of the motion of the parachutist, the effect of air resistance is included before her parachute opens. And this refined model is now used to find a new value of t. How will this new value of t compare with the value found using the initial model? Okay, well, t is obviously the time it takes her to get to the ground, right? So if there is air resistance, is it going to take her longer, or is she going to be quicker? Well, it's going to take longer, isn't it? Because the air is slowing her down, right? If she's falling down, the air is at least, slowing her down slightly, isn't it? Because it's a resistance, it's a resistive force that opposes the motion. So it's obviously going to take her longer. So the value of t is going to be greater. And the last part says, suggest one further refinement to the model apart from air resistance to make the model more realistic. I've been skydiving, right? I'm not even trying to impress you because I landed about 2 miles out of where I should have done in a field full of cows. But that's another story. But when I skydived, I didn't go in a straight line. Like, you get that parachute up and you are flying about. Like, absolutely no chance that you jump out the plane, so go down, parachute up, down. That's just not what happens at all. So basically, there's loads of things, right? But I would probably say in this case, I would say allow for the fact, allow for motion in other dimensions, right? And not just vertical, in other directions. Not just vertical, because you actually steer. You have these things that you pull, and you go like that, and you're turning about, and if you're me, you could do it completely wrong. But so that would obviously change the time greatly, right? Because the total distance traveled would be so much more if you're going horizontally in all these dimensions as well, than if you're just going straight downwards. Question 2, the writing man. A small ball of mass 0.8 is held at rest on a smooth table and is attached to a thin rope. Rope passes over a pulley, fits the edge of the table. Other end of the rope attached to Q, mass 0.6, hangs freely below. P is released from rest. Rope taut, P is a distance 1.5 from the pulley, height of 0.4, blah, 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 blah. Q descends, sits the floor, does not rebound. Ball model particles, rope is all that normal stuff. Using this model, show that the acceleration of Q as it falls is 4.2. Get the diagram up, get the forces on it. So let's look at Q. We know we're going to have a weight going downwards, which is going to be mg, so 0.6g. We're going to have a tension going up, and it's going to go through the rope. That same tension is going to be going this way, because it's obviously pulling P that way. There's actually no friction here because it's a smooth table. So interestingly, there's no resistive forces on P. In reality, there will be, but because, you know, we're making assumptions here, there's not. So that basically means that in terms of like the horizontal stuff, that's everything that's going on with P. Now you're also going to have some vertical forces, but I don't think we're going to really care too much about those in this question. So all you need to do is F equals ma. We need to do that because they're accelerating. So Q is going to accelerate downwards. So if I was to do F equals ma on Q, it's going to basically be the resultant force downwards is the F bit. So it's going to be down, take away up equals ma. So down is 0.6 g, t is the up, and then it's going to equal m, which is 0.6 times a. Let's do the same for p. It's accelerating to the right. So for p, it's going to be right minus left equals ma. Right is the tension, so t, and there's nothing taking it left. And that is going to equal 0.8a. So I've got two equations here. If I was to add them together, what would I get? I would get 0.6 g minus t plus t on the left equals 0.6a plus 0.8a on the right. So the t's are going to cancel, so I'm going to get 0.6g equals 0.6a plus 0.8a, which is 1.4a, divided by 1.4. So a is 0.6g over 1.4. So I'm assuming g is 9.8 here, so 0.6 times 9.8 is divided by 1.4, which is 4.2, which is what they want. Sick. Find the time taken by P to hit the pulley from the instant when P is released. There's going to be a bit popping off here. Let me tell you why. Let me tell you why. There's two sections of motion, right? The first section is Q going down by this 0.4, and then equally P moves with it, right? So when this happens, and this goes 0.4 this way. Before we think about the next section, let's just set up a suvat for this so we've got it on the paper before our minds get filled with mechanics and we don't have a clue what to do with our lives. So suvat. We know that this green section is 0.4 meters. We know that for this the acceleration is 4.2 because we just worked it out. We know that u is 0 because it's released from rest. So we can work out two things here. We clearly want the time because the question is asking us for a time. So let's work that out. But then I actually think we're going to want v as well, and we'll talk about why after. So let's first of all get the t here. What can I use? I could use s equals ut plus a half at squared. So s equals, well, let's just write it here because I want to avoid how much I have to write down for this question. It's going to get very messy. So s equals ut plus a half at squared. So 0.4 equals ut, but u is 0, so that's gone. So ut is gone. Half at squared, so half a t squared. I can work out t from that, can't I? Because it's going to be the square root of times by 2, so 0.4 times 2 divided by 4.2. It's going to be that, isn't it? So let's work that out quickly. So get a fraction, 0.4 times 2 over 4.2, and that gets me a grim surd. It's going to be 0.43643 blah de blah. That's 5 sig fig. That'll be enough for now. Okay, let's think about the second section of motion. What's going to happen after this 0.4 meters? Q is going to hit the floor, and it's not going to rebound. P is going to be here. It's going to be 0.4 meters further. So P is now here, leaving a distance of 1.1 meters to the pulley, right? What forces are going to act on P at this point? If Q hits here and P is going forward, the string's going to become slack, isn't it? The particles are now not keeping that string taut, so there is going to be no tension. There is going to be no pulling of P from that string, right? Therefore, there's no tension going this way. There's nothing going that way, right? It's smooth, there's no resistive forces. There is no force to actually change P's velocity at all. So here's the thing, right? absolute storm outside. If we were just gonna, P already has velocity coming into this because it already has that momentum from the first bit. Let's work that out. That's going to be its velocity all the way till when it hits the pulley, isn't it? So if we were to work out v from this green section of motion, given that we do know the value of t as well, right? So, I mean, you can work out any v. Let's just do it with these because that's a grim value. If I did v squared equals u squared plus 2as here, what would I get? U squared is 0. So v is going to be the square root of 2as, which is 2 times 0.4 times 4.2. Stick that in your calculator and you'll get 2 times 0.4 times 4.2, which is another grim number, 1.83303 ... Okay, so if we now think about this yellow bit of motion, it's actually quite simple. Because if it's got a constant velocity, surely it's just a speed equals distance over time, right? So speed, which is this thing here, you know, the 1.8 blah-de-blah, equals distance, which is 1.1 over time. So the time is just going to equal the 1.1 over this thing. 1.83 blah-de-blah-de-blah, but I've got that as my ants, haven't I? So if I was to just do, this is going to be t2, right? So let's, you know, as in the t for the second bit of motion. So let's do 1.1 divided by ants here. That gets me some other grim surd, right? It's basically 0.6, but it's got like some zeros and then some other stuff later on. So that's the 0.6. Add that to the first t, which I got as this, and that should be the answer. So this I've got stored as my ants. So my final time, let's call it big T, is just going to be that stuff there in the yellow. I'll just write T2 for here because I've got it here, plus all of this stuff. 6, 4, 3, blah, 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 to finally get my final answer as ants plus 0.43643, which I'm going to get as 1.0365 da-de-da-de-da. How many sig figs do we really want this? Let's go 3. So that's going to be 1.04 seconds. Pretty grim. State one limitation of the model. Well, basically, look how many assumptions they've given us. The balls are modeled as particles. The rope as light and inextensible string. Pulley as small and smooth. Horizontal smooth table. Like so many. Just choose any. Choose absolutely any. Let's just say the pulley is smooth. In reality, what would happen? Well, there'd be a bit of friction at the pulley, which would then take some energy out of the system, change the velocities, change the times. There are many assumptions that we make in, you know, the A-level mechanics course that would really affect the real world answer. Question 3. A particle P moves along a straight line such that at time t seconds, the velocity of P is modelled as 12 plus 4t minus t squared. So this isn't SUVAT, right? SUVAT are the equations of like constant acceleration, but once we're given these like functions of t that have quadratics and stuff in like that, then you're not in the realms of constant acceleration anymore. We use calculus. We use the fact that to get the velocity from the displacement we differentiate, to get the acceleration from the velocity we differentiate, rates of change, stuff like that. So we want the magnitude of the acceleration of p when p is at instantaneous rest. So there's a couple of things we need to do here. What does instantaneous rest actually mean? It means you're at rest. You ain't moving. So here's the thing. What is your velocity going to be if you're at rest? Nada. It's going to be 0. So to find the times when it is at instantaneous rest, all I need to do is set the velocity function equal to 0. This is a quadratic. You can do whatever you want to solve this. I will multiply by -1 and I'm going to factorize it because the numbers look all right here. So I think I can factorize this because if I had a +2 and a -6, I should be laughing. So I'm going to get two solutions here. -2 or 6. Now t is a time, so it can't be negative. So this is the one that I want. I now need to get the acceleration function. And as I said before, the acceleration is the rate of change of velocity. It tells me how my speed is changing. So acceleration is the derivative of the velocity with respect to time. So all I need to do is differentiate this function here. 12 goes to nothing, 4t goes to 4, minus t squared goes to -2t. So when t is 6, my acceleration is going to be 4 minus 2 times 6, which is 4 minus 12, which is minus 8 ms to the minus 2. Is this my final answer? No, because it's asked for the magnitude of the acceleration. In other words, the size. This minus 8 is saying, look, you accelerate in 8 meters per second squared, but in the negative direction. But I don't care about the direction when I'm asked for the magnitude. It's just like, well, how big is it? It's 8. So I would therefore say magnitude of the acceleration is just 8 meters per second squared. It just doesn't care about the direction. Okay, part B says the distance travelled by p in the interval all of this. Remember when we had a velocity time graph in the other question? We, with a parachutist, and we did all of this stuff, or whatever it was, and we were like, oh yeah, the distance travelled is the area under the velocity time graph. Well, that's no different now, is it? It just so happened that then we had all these nice straight lines and constant accelerations and stuff, but we still, I think we had t here, didn't we? We still use the fact that the area under was the total distance travelled, right? Here's the thing, we have now got some curve for the velocity, right? I don't know, maybe it looks like, again, I'm not going to draw the actual function, but just to give an example, it does something. It's not nice straight lines that we can split up into triangles and rectangles and stuff, but it's a velocity time graph, we've got its function, and we need the area under it. How do we do that? We integrate, don't we? So there's actually no difference between what we did in the other question and what we're doing now. It's just to get the area itself, we need to integrate instead of just splitting up into nice rectangles and trapezia. So all I need to do to get this distance, right, is I just need to do the integral between my limits, which in this case is 0 and 3, right? So, this would kind of be 0 and 3. I know that this function doesn't look like that, by the way, of the velocity, right? So 12 plus 4t minus t squared. And then that is going to be my final answer. So let's integrate this. It's a definite integral, so I want my square brackets. 12 goes to 12t. 4t goes to 2t squared. Remember, I'm adding 1 to the power and dividing by the new power. And then this is going to be minus t cubed over 3 between my limits of 3 and 0. So I'm just going to have one bracket, which is me subbing 3 in. And then the other bracket, which is me subbing 0 in. But if I sub 0 into all of these terms, I'm just going to get 0. So the only thing I need is just working out this, right? So let's do it. 12 times 3 plus 2 times 3 squared minus 3 cubed over 3 gets me 45. And I believe this is in meters. And that is it.